Hello, everybody. Hope we are all doing well and staying safe. My name is Alex Lepore, and I am with Fortress Power. I want to thank everybody here for joining the webinar that I will be hosting today, along with the good people over at RENVU. And I want to take this moment to thank you all for taking some time out of your days, and while you're either sitting at home or at the old home office, for taking some time to join our webinar today. Today's webinar is going to be regarding the FAQs of lithium energy storage. So without further ado, I'll get started. So a few things that we're going to talk about during this webinar is we're going to do a product introduction. So I'm going to talk a little bit about the different Fortress models that we have. I'll then go over a battery technology comparison regarding the different chemistries of batteries that are typically seen on the market. I'll also go over a design guide regarding how Fortress can help size some of these different battery projects you may be working on. I will then let RENVU take over the ropes and talk about some of the different services and tools that RENVU offers through their online portal, which I was very impressed with, and I'm sure that you will also be impressed with in that way. I will then close out the presentation with some of the benefits of being an authorized installer of Fortress Power equipment. So with that being said, let's get this started. So Nick, I'd like you to talk a little about RENVU company overview before we get going here, and I'll hand this over to Nick of RENVU. Nick?
Hey, how's it going? My name is Nick May. I just want to give a quick overview of our company, kind of what we do, where we're based out of, before we start jumping into talking about Fortress and their products. So we're a distributor based out of Mountain View, California, founded in 2012. We since then have spread out through the United States. So we have fulfillment centers located in California, Texas, and New Jersey. We're actively looking at expanding into any area that we think would help shorten lead times and make delivery easier for any of our customers. Our sales team, who you'd primarily be speaking with if you called in, is comprised entirely of engineers, and we did that specifically to try and make sure that they understand the products, like Fortress's batteries, that they're talking with you about and working on designs with you, so they can act as that first level of support when you need help on any project, be it when you're designing through the permitting stages down to the actual install, or any troubleshooting that you might run into. As well, we focus a lot on trying to design a lot of free online tools to help design products, generate bill of materials, and kind of everything in between, just to make, as an installer or someone who's out selling energy storage or solar to homeowners, as easy as possible, so that you can get through the sale and close it and do the installation. Yeah, if you want to jump to the next slide, I can just, cool. So having said all that, it kind of ties into our mission here, which is to deliver quality solar products at the best prices with an exceptional level of knowledge and support. And so a lot of the work that we do in terms of having a staff of engineers, trying to design and implement as many tools as we can, is based around trying to provide that level of knowledge and support, and then keeping our prices as competitive as we can, so that we can help you win as many projects as you can.
Hey everyone, my name's Chris. I'm with RENVU Solar, and it's a pleasure to be here with you today. So I'm just going to be walking you through our solar design tool online. This is a really great tool for installers to use to quickly design their own systems based off of a few simple parameters. So today we're going to be going through the battery backup guide. So Nick, if you could click on the battery backup section. Yes. And then next, you see a couple of checkboxes here. So you can unclick the full system or click the full system if you want a full system. Otherwise, you can pick exactly what you want, whether it be only panels and inverters and so on. But we'll stick with the full system today. And then today we know the number of panels and the brands we want to choose. However, we can help you calculate the number of panels if need be. And if you don't know what products to use, then we'll choose for you something that's compatible with the system that we're designing for you. So if you want to go ahead and click next. Great. So here are all the, well, these aren't all of our options that we offer in terms of panels, but this is a a fair amount of the options that we offer. If you want to stick with the Paymar 310 watt all black panels, that'd be great. That's one of our best selling panels. So after choosing your panels here, we're going to be choosing the racking. So you have 3 choices up top for tilted roof, flat roof, and the ground mount. We'll stick with the tilted roof with the composite shingle roofing, but there are other options for different attachments if need be. And then for the panel layout, you can choose the number of arrays, you can change your number of rows and the number of panels per row. So today we're going to be doing 10 panels, 5 panels per row. So that's 2 rows, and then as you can see, we're doing 5 panels per each row. And then, so if you want to scroll down, we can do unirack racking. For the roof attachments, we can do quick mount PV, but we're going to stick with unirack just to keep the brand the same. Since we have all black panels, we're going to choose all black rails and black clamps just for that nice all black aesthetic. And then we can change the standoff span here. So 4 feet's pretty conservative, so we like to keep it at that. And then the rail profile. So Unirac has the light and standard duty rail, but we'll stick with the standard, which generally meets all cases. And then you can go ahead and scroll down. So that's the layout right there. It shows the dimensions. Sorry, Nick, if you want to scroll up real quick and show the left side where it shows the bill of materials. Yeah, so as we've been going through this, you can see the amount of power for the DC power for the system, and then the bill of materials thus far, and the cost. So something to keep in mind is if you want to change the roof attachments or brands, the pricing will change. So if you're trying to better meet a certain budget. Yep, so you can go ahead and click next. All right, so here we have the inverters. So we're going to stick with the SolarArc today because generally we like to pair SolarArc with the Fortress battery. And then you can choose the temperature range of your location, which will change some of the parameters in terms of inverters and batteries. The 8K will suffice, the SolarArc 8K. If you see, we offer the SolarArc 12 and the 8K. And then for rapid shutdown, for most residential systems, we're going to be needing that. So we'll keep that at yes. And then we want optimization, so we'll stick with those Tigo TS4 AOs. And then you can click next. So if you need help calculating the battery bank size, it's similar to what Alex was showing earlier with the critical loads consumption report. So if you know that information, you can input that here where the mouse is showing. Otherwise, if you know how many batteries you want, then we can go ahead and click yes up top and then move forward from there. And then, so we want to do lithium ion choices. And then, as you can see, we have the Fortress Power options here. There's the 10, 18.5. So let's do two of the 10s. Go. All right. So we've picked the batteries, and now we're on the balance of system materials, which is the cables, connectors, disconnects, combiner boxes, and so on. So generally, we're going to want all those tools for a turnkey solution. So all that equipment that's listed in the check boxes, PPE, and if you have vent pipes to relocate, you can choose those if you need to, if necessary. If you have a critical loads panel, this is pretty important. Most battery backup situations do have it, but if you don't, if you click no, that's gonna change your bill of materials such that your system will work without a critical loads panel. Something to think about is that you'll likely need a whole home transfer switch if you don't have a critical loads panel. So that's just something to keep in mind. And then right below that, you see there's the smart energy monitoring, which we like to add onto systems with batteries, just because it's so crucial to be monitoring your energy consumption if you're going to be going purely off the battery and solar. And then at the bottom, so RENVU does permitting and wiring line diagrams. We also have professional engineering services as well. So if you need any of that, those services for getting your plans approved, we can help you out with that. And then as you can see on the left side, there's our bill of materials thus far. And then at the bottom, when you click finish, that'll finalize the bill of materials for you. Great. So yeah, now you can see all of the materials that that have been generated based on the system that we've created for you. And then if you scroll up to the top, you can actually generate a quote for yourself, and it'll email it to you as well. Yeah, and that basically wraps up the battery backup portion of this all. So as this is loading, I should tell you, so we have the regular solar kit guide, which is for grid tied situations. This is the battery backup guide, and then we also have an off-grid section, which is for non-grid tied applications. I'm sure you're all aware of. Let's wait till this loads. Okay, great. Okay, yeah. So now under the project section, so that quote has been also downloaded to the Nick's account. So he can name his project. He can, if you look on the right, there are different options for how to handle this quote. And then if you scroll down, yeah, it shows you all the bill of materials, and then you can edit the quantities after if you need to. Yep. And okay, so that about wraps up that part. And then so something also I should add we also have a battery upgrade guide. So this is generally for AC coupling systems. So if you already have an existing system, you can use this upgrade guide. And all it really entails is you inputting the current specifications of your existing system. And then from there, we can develop a bill of materials to allow you to add battery storage onto the system that you already have. So that's a really handy tool if you need to retroactively upgrade your system with battery storage.
So do you want to talk about on-site analysis and professional engineering services real quick?
Sure, yeah. So for we offer PV on-site analysis. So when you're qualifying and designing commercial scale projects, typically one of the many challenges that these projects will face is to get thorough site information to have a good understanding of what they can actually install and why they would want to install it. So we offer site reports, including power production estimates, electrical evaluations, structural viability, shade analysis, environmental reports, and so on. Whatever you need, you can request, and we have a pretty flexible team in terms of the on-site analysis. And then also, we offer professional engineering services. So as you saw earlier, we offer the permitting services, and which entails the site plans, wiring diagrams, and other structural reports. But if you also need professional engineering services like a PE stamp, professional engineering stamp, whether it be structural or engineering, we can offer that as well.
Cool. And then just a couple of the other things here, logistics, warehousing solutions. Like I said, we have warehousing in 3 different states currently, but we have a wider network of warehouses that we work with. So if you ever have projects that you're going to be delayed on and you need a storage solution for the time being, we can offer some pretty competitive rates on the material, as well as storing it near to the location of the job site and then providing final delivery to wherever it's going to be. So you can ask any of our sales team about that and then go into more detail. As well, we offer a program where we'll purchase excess inventory. Say you have projects that weren't completed or something changed on them and you've got excess inventory, you can always reach out to our team as well, and we're happy to take a look at any of that inventory and potentially purchasing it back, even if it's not something you purchased from us, just because we want to offer that flexibility and make sure that you're able to capitalize on the equipment that you purchased and are getting your money back on it.
Nick, thank you for the introduction. I'll now go over a little bit about Fortress Power and the product line that we have here with us. So to start, Fortress Power We are based in Southampton, Pennsylvania. It's around, say, 25 to 30 minutes outside of Philadelphia. You can see our facility here. It's a 30,000 square foot facility for a lot of the research and development, sales, quality testing, and logistics for our battery systems. You can see we even have a little solar array here on this part of the on this part of our warehouse. We also have logistics centers in California and Florida, and worldwide we've done over 45 megawatt hours worth of battery installations and have helped out with them from the Caribbean to the continental US to Canada and even a little bit in Africa. So we're really starting to see a lot more growth with energy storage, especially as the demand goes up and people are moving away from the traditional lead acids, which I'll be talking about later in the presentation. We're also the exclusive battery supplier for a local railway company here in Pennsylvania. So we're seeing a lot on the residential side, as well as moving into the commercial and utility side. Residential or utility scale energy storage has its importance all around. We offer 3 different kinds of batteries. So we have an 18.5 kilowatt hour model, which is most likely our flagship model. We see a lot of success with this because of its ability to parallel not only up to 12 for 200 kilowatt hours, but it also has this LCD display. I'll go over this LCD display in the next slide. But for smaller projects on the residential side, we also have our 10 kilowatt hour and a 5 kilowatt hour battery as well. So anywhere ranging from 5 kilowatt hours to 200 kilowatt hours, the small residential to small commercial, we can really fulfill a lot of those projects in that range. So I mentioned that the eVault's LCD display. This is what that LCD display looks like. So right on the front of the battery, the client will be able to view their voltage of the battery, the state of charge of the battery, the current, and the power. What you'll also see is on the bottom left, this MSET. This is if you have multiple batteries in parallel. So I mentioned you can put up to 12. So if this was the master battery, the other batteries in parallel would be a slave. So it has a master-slave relationship. And then this number here is going to show your parallel number. So if there's 1, if there's 6, if there's 12, let's say, this would show how many batteries are in parallel in the bottom right-hand screen. Another cool feature of the LCD display is if you see here on the right-hand side, there's these little circles with these HV, LV, HT. These are the safety features on this LCD display. So should there be, should something happen in regards to the battery and the homeowners at home and they see LV pop up, they then know when they call you, hey, I'm seeing an LV on my screen, it means low voltage. This really will help you start to diagnose the different problems should one arise. And then when you contact us at Fortress Power and our technical support team, it'll allow us to give the best service and knowing where the problem stemmed from, what the diagnosis is, and then how to fix that problem. So I like this LCD display because it's really a peek inside the battery that not a lot of different batteries have on the market. So just one thing I wanted to bring up in that way. And then this is going to be our newest product that we're releasing, the eFlex 5.4. So this unit will be available in June 2020. This unit will be a 5.4 kilowatt hour unit total, which can then be paralleled up to 80 kilowatt hours. Some cool features about it is that it will have this closed loop communication with the different inverters that we're compatible with. It'll have a memory card for data storage. You can use it for Wi-Fi remote monitoring. So you'll be able to get a cloud-based app to see how the battery is performing. And this battery can also be wall-mounted, floor standing, or put in a racking or shelf-mounted solution. So in that kind of way, you have the eFlex in the rack. You can parallel racks together to increase your amp hour capacity. I'm really excited for this unit, not just because of all these really cool features, but it also looks really clean, as you can see here, and it'll have a lot of the things that a lot of, I think, customers are looking for with the monitoring, wall mountable, and then data storage with the memory card. So I'm very excited to see this come out, and like I said, June 2020. So here's a technical specification sheet on the 4 models of batteries we do have. I'm not going to go over each one of these criteria, but there are a few things that I would like to point out. The first thing is that all of our batteries are 48 volt nominal. So that being said, we are compatible with a lot of the 48 volt hybrid inverters on the market, and I have a quick chart later in the slideshow which I'll be able to run through. Like I mentioned, the E-Vault can stack up to 12 for 200 kilowatt hours. The E-Flex can go up to 15 for 80 kilowatt hours. You can put up to 2 10s and 3 5s. All of our batteries come with a 10-year warranty in the United States and a 5-year warranty outside the United States. We guarantee up to 6,000 cycles at an 80% depth of discharge. And what's interesting about the E-Vault and the E-Flex in particular is that they'll have this CAN communication with an RS-485 cord. So when you have multiple batteries in parallel, this RS-485 cord will allow the batteries to talk with one another as they either charge or discharge for the particular project. So one thing I did want to mention, and that is important with the lithium that's different than a lead acid battery, is the battery management system. Battery management system is essentially the brain of the battery, which is going to prevent against overcharging and deep discharging, overheating, overcurrent, short circuit, open circuit protection, things like that. So on the E-Vault and the E-Flex, it's a contactor-based battery management system, meaning that's a physical fuse and switch that opens up. So not only will it have this protection against this overcurrent and overheating, but it also allows the batteries to communicate with the inverter, communicate with the other batteries in parallel, and then allow for remote monitoring. So I mentioned with the E-Vault, for example, when you have 6 E-Vaults in parallel, this kind of BMS allows those 6 E-Vaults to communicate with one another, and then the inverter put into that. The cells in both of these units are a prismatic cell. So the difference between prismatic and the cylindrical over here on the 5 and the 10 is that the prismatic is a square shape, and that's very much so efficient, a little bit more efficient than the cylindrical, although both of them are lithium iron phosphate chemistry. It's just a different way to approach the cell type. The 5 and the 10 have a MOSFET-based BMS, so although it does have these really good features of preventing against overheating and overcurrent, short circuit, and cell monitoring and balancing, it's not like the contactor-based BMS in that it does not have that really kind of thorough communication with the inverters or communication with the different units in parallel. So as we move towards, I think you'll see a lot more batteries have this contactor-based BMS. Although it may be a little bit more expensive, you're getting a lot more insight into the battery and a lot more safety to prevent against these different overcurrent, et cetera, et cetera. So I'm going to go over a quick battery technology comparison of the different chemistries that you typically see on the market. So here on the left, you'll see LFP. This is ours, lithium iron phosphate. This is lithium ion. So this is something like a Tesla or an LG Chem would use. And then we have a lithium polymer. This is similar to the kind of battery that's in your phone. Your flooded lead acid batteries, AGMs, and then nickel iron. A few key things I would want to point out is the round trip efficiency of the LFP is extremely high, 98%. Wow. Even in comparison to the lithium ion, the really high round trip efficiency really just is a great benefit to lithium in that you're able to maximize the solar production and then power those loads. Another thing is the energy throughput, 47 megawatt hours. Energy throughput is the total amount of energy a battery can be expected to store and deliver over its lifetime. So we can calculate energy throughput by taking the nominal capacity multiplied by the depth of discharge, multiplied by efficiency, multiplied by the cycle life. So in comparison to some of the other battery options, you can see LFP has a very high energy throughput in comparison to an AGM or even the lithium ion. The only one that really comes close is this nickel iron. But then if you look at the cost of a 10 kilowatt hour battery, you can see it's almost 3 times the amount of what an LFP battery would cost for the same size. This ultimately comes down to the cost per kilowatt hours, where LFP, you're basically getting the most bang for your buck. At 0.14 cents a kilowatt hour, you're really getting long life cycles, a cheap cost for those life cycles in that kind of way. And obviously LFP is very safe, and there is no maintenance like that with a flooded lead acid or a nickel iron battery. So I'm going to go over a quick performance comparison of LFP versus lead acid. So I have this chart because you can see as current goes up, with an LFP battery, your capacity stays consistent. meaning that as you provide more current, as more current goes through the system to power loads, you're not going to lose capacity. Now, if you look at these, this looks like a flooded lead acid. You have an AGM and a gel battery. As your current goes up because electricity goes out or using it for another application, as the current goes up to power the loads, you're losing capacity. And the key point with this is that you can really have a lot of current push out to a lot of loads and still keep your capacity pretty nominal and not have to worry about your capacity dropping as your current goes up. And I mentioned those different chemistries, the lithium iron phosphate, the lithium ion or nickel manganese cobalt, and then the lithium polymer. So the reason why we use lithium iron is because of the safe technology in that. So lithium iron is very safe, it's very eco-friendly, it can be recycled, and it's very thermally stable. I mentioned an 80% depth to discharge, we guarantee 6,000 cycles, while some of the other chemistries, although lithium ion may make sense for vehicles like the Tesla car because they need to have a lot of power to move the car from A to B, it doesn't really make too much sense for a standalone energy storage system where you're trying to get a lot of life cycles to power the electrical loads. So LFP, I would say, is best for stationary applications like energy storage, while NMC would be great for vehicles with a needed higher energy density to move that vehicle from point A to point B. And you can see here with the lithium polymer that it is kind of like the battery in your phone. It doesn't have a lot of life cycles. It's not too safe, and it really isn't too eco-friendly. But in that kind of way, there are some applications that lithium polymer can be used for. But typically, with the energy storage side of things, a lot of applications are now starting to use lithium iron phosphate. So a quick video I like to show is the proof behind the pudding, right? The safety of the lithium iron phosphate chemistry comparison to the nickel manganese cobalt chemistry. You can see here on the left, this is an LFP cell. So this is a 10-penny-inch nail. They drill right through the center of this LFP cell, and you can see throughout the video that it smokes a little bit. There's a little bit of smoke that comes out, but nothing too severe. Over here, on the other hand, you go to the nickel manganese cobalt technology and they do the same kind of test, and you can see that it really just explodes, simply put. And that's why we choose the LFP cells in the lithium iron phosphate chemistry, because it is much safer than the NMC or the lithium polymer that some other approaches use. So you go into YouTube and search LFP versus NMC nail test video, you'll be able to find the full video on the YouTube channel. So the LFP technology advantage, it's obviously very safe, has superior safety, a very high energy throughput, 47 megawatt hours, long duration, 6,000 cycles and 80% depth of discharge, and a low energy cost, so 14 cents a kilowatt hour. You're really getting the biggest bang for your buck. So I'm going to go over a quick design guide that we have here at Fortress Power to help size some of these different projects depending on the different application. Before I get started on that, I want to go over some of the different inverters that can be used with our different batteries as you do some of your designing. So we are compatible with the Schneider line, the Outback, Magnum, SMA, Solark, Victron, Morningstar, and Midnight. And the ones where you see asterisks are the ones where we're establishing a closed loop communication with those inverters. So I always say not one battery can fit all projects, just like not one inverter can fit all the different kind of project applications. So that's why we have a lot of compatibility with these different inverters, gives us a lot of flexibility with these different projects, depending on what you're used to and what you found success with in your experience. So now I'm going to go over our energy storage sizing tool. So our sizing tool encompasses finding out, let's say it's an emergency power application, finding out the critical loads of the project. So here I have you have a refrigerator, some lights, a sump pump, a well pump, an electrical range, a microwave, TV, a lot of these critical loads that a typical person would want in the event of an outage. So what we can do is we can figure out all of these loads and figure out the watt hours a day of consumption that these loads would take over a period of time. Then what we can do is figure out what size battery would be appropriate for that. So I did two LFP10s, which are each 10.2 or 10.2 kilowatt hours or 10,000 watt hours. Two of them together at a 90% depth of discharge gives you 18,432 watt hours available in the battery. So then what you can do is the battery is obviously sized for those loads on the previous page. So you can find the average daily PV production. This is also on our sizing tool, and you can figure out through a PV watts report the AC energy and energy per day in watt hours. And then you can figure out, based on one full charge on the battery, this will be the available energy after the battery charged. So you can tell somebody, okay, during June, you'll be able to produce 36,000 watt hours a day. You'll charge the battery, which means you'll have 18,000 watt hours available after it is fully charged. So that can either go back to the utility for net metering, or it can go right to the electrical loads in the house. Now in December, on the other hand, you're not producing as much energy per day. So you'll charge the battery, but notice that the available energy after the battery is charged is significantly lower in June than it is December. So this is something where when you're communicating or when a question arises like this, you can say you just need to be careful in December because typically you'll have less energy available after. So just be careful with your consumption in that kind of way. So then we have the available power in the battery at 90% depth of discharge is this 18,000 figure. The lowest average daily available PV power is 20,000 watt hours. Highest is 36,000, which means that it's going to power these loads with two of those batteries at a 90% depth of discharge for one full day. So I can always do a more thorough training on our sizing tool and going through those steps if need be. And we do have a sizing tool that we are available to share should you have more questions regarding our sizing tool.
Next, I want to talk about this LFP discharging curve. So if you remember earlier in the presentation, I mentioned that the EVOD has the LCD display on the front to measure state of charge. The eFlex will have remote monitoring. You might be asking yourself, how would I measure state of charge or capacity on the LFP 10 or 5? What you would do is take a voltmeter and figure out the voltage depending on the C rate to figure out the capacity. For example, 0.5 C, we measure the voltage. Let's say the voltage is at 50 volts. We then know that the capacity of that battery is at 80%. So it's just a quick tip for those of you that are wondering how to measure the capacity of the LFP 10 or the LFP 5 battery. Next, I want to bring up the temperature impact on lithium iron phosphate. So LFP has a very broad discharging and charging temperature. It can really range from 32 degrees Fahrenheit to 130 degrees Fahrenheit. And you can see here that the stipulation with temperature is it's not as it gets colder, even to the -4 degrees Fahrenheit, it doesn't stop charging or discharging. It is the rate of the charging or discharging which is affected. So although our batteries are primarily an indoor unit, which we really do recommend, should it be somewhere where it can be subject to colder temperatures or maybe warmer temperatures, the broad discharge and charge range will help, but at the same time, it'll be good to know that the rate of the charging and discharging will just be slowed down. Next, I want to look at cycle life versus depth of discharge. So as I mentioned, we recommended an 80% depth of discharge for the 6,000 cycles. If you were to cycle that one time a day, that's around 12 to 15 years. The reason why I put this chart here is because some of their batteries claim to have 12,000, 13,000 cycles. But what they're not telling you is that this depth of discharge is only at a 50% depth of discharge. So if you have a 10 kilowatt hour battery, you're only able to get 5 kilowatt hours out of that. So depending on the application of the project, whether it's a time of use rate, maybe 80% or 70% might be the way to go. But if it's a emergency power, you could really go to 90% or even 100% depth of discharge, depending on what the project calls for. For long life cycles, 80% would make sense since they're cycling it daily, i.e. time of use or off-grid. For someone emergency power who needs a lot of power, a few times a year, 90% depth of discharge or 100% depth of discharge might be the avenue to go. So always be cautious of when people say how many cycles they have, because it really depends on the depth of the discharge, their temperature, the temperature in the area, along with the charging and discharging parameters. So please note this moving forward regarding cycle life, along with warranties. So a lot of the different parameter setting guides for the different batteries we have with those different inverters can be found at fortresspower.com/resources. But a thing I did want to bring up here is that we recommend 80% DoD for 6,000 cycles, 90% DoD for 3,000 cycles. Max charge current, 100 amps for the eVault, 90%, 170 amps. So with more depth of discharge, you will be able to put out more amps. More information on parameters and with the different inverters can be found on our website, like I said below. So if there are these other applications in which you're sizing a project for something along those lines, like the time of use, self-supply, or for demand curtailment for maybe some commercial projects, you can send your project information to sales@fortresspower.com, and I'd be glad to have a few of my application engineering staff take a look at that and see what kind of recommendation we could come up with in that regard. RENVU also offers a few installer services like on-site analysis, professional engineering services, logistics and warehousing solutions, and purchasing excess inventory. So please reach out to your local RENVU representative for any other questions regarding that. And the same with RENVU's solar kit guide and battery upgrade guide. Essentially, they're very helpful tools to help figure out for a particular project what a bill of materials may look like, or what a battery replacement may look like for a lead acid to lithium or another solution in that way. So please contact your rep at RENVU again with any questions in regard to their design tools. If you're interested in becoming an authorized installer for Fortress Power, what we will do is you will fill out the dealer application that we have. We will then provide the product and sales training with a webinar, somewhat like this one, but maybe more on the installation side. And then we will then end up with the design and installation training. So a lot of good benefits that our installers have is the sales and marketing support that I provide, the discount price that you'll get as an authorized installer. You'll get generous stock levels, technical support, and trainings for your team or for your customer. Thank you very much for listening to this webinar. And if you want to go fast, go alone. If you want to go far, go together. Please feel welcome to reach out to us at Fortress at sales@fortresspower.com, or for questions regarding RENVU's sizing and design services, please email them at info@renvu.com. Thank you again, and have a great day.
Okay, great. Thanks again, everybody, for joining, and keep an eye out for responses to those technical questions. If you have any other questions, feel free to reach back out to anyone over at Fortress or here at RENVU, and we're happy to help. Thanks again for sharing, and hope everyone is staying safe, and look forward to working on some projects with you here in the future.